Okay, let's unpack this. We are diving into really a major wave of announcements, and they seem entirely centered on making building with AI incredibly faster and maybe more importantly, just architecturally accessible.
Yeah, accessible is a good word.
It feels like a shift, not just iteration. It's like a seismic shift from AI as something people maybe play with occasionally to something people build with reliably at scale every single day.
And, before we even get into the specific products, I think it's crucial to set the stage with the sheer reported scale of acceleration here. It really helps grasp the magnitude of change we're looking at.
Absolutely. The numbers are pretty staggering, but they do tell a story, don't they?
Yeah.
About who's using this platform now, not just how many.
Exactly. If you think back just to their initial developer day in, 2023?
Yeah, it feels like ages ago now.
Right. At that time, the platform supported about 2 million weekly developers. They had 100 million weekly ChatGPT users, which was huge then.
Totally.
And the API, which is really the raw computational engine behind all the enterprise stuff, the custom apps, that was processing roughly 300 million tokens per minute.
And that felt like a massive volume just a couple of years back. That was the benchmark, right?
That was the state of the art. Now, compare that benchmark to today's reported reality, the developer base. It's apparently doubled. 4 million people actively building.
Okay, doubled.
The user race for ChatGPT itself has just skyrocketed, over 800 million people weekly.
Wow.
But impressive as those are, they mostly tell us about, front-end consumption, the number that really signals this tectonic shift in enterprise adoption in mission-critical workloads. That's the API processing rate.
Which has jumped to?
It is now reported at over 6 billion tokens processed per minute.
6 billion per minute. Okay, let's just pause on that for a second, because that's not just double. That's a, 20-fold jump in raw computational output.
20 times, yeah.
That doesn't just mean more developers tinkering. It implies the use cases themselves have become way more complex, right? More computationally dense, built into the fabric of large enterprises that just demand massive throughputs.
Exactly. That's the engine humming beneath the hood.
It suggests the AI is moving beyond simple Q&A tasks to orchestrating really complex multi-step workflows, handling huge data loads, running these agents that need deep reasoning across all sorts of inputs.
Yeah, and all those things just consume tokens exponentially faster than a simple conversation.
That number alone frames our deep dive perfectly, actually. So our mission today is to understand the 4 major architectural pillars they introduced that seem to enable this exponential acceleration that support that 6 billion token per minute reality.
Right.
We're talking the apps SDK, the new agent kit, a mature codex now running on a specialized model, and of course, powerful updates to the underlying intelligence itself. We'll focus on the how and the why. These tools fundamentally change the developer landscape for you, the builder listening right now. Okay, let's kick off with the apps SDK, because this feels like it changes the very nature of the ChatGPT interface.
The big architectural idea here seems to be moving beyond the static plugins or simple integrations we saw before.
Right, the early attempts.
Yeah, towards building fully interactive, adaptive, and personalized applications inside the ChatGPT interface itself.
It really is a transition. It's like the model is shifting from being a standalone brain to becoming the central operating environment almost. The apps SDK, which they're launching in a dedicated preview, gives developers this crucial full-stack capability.
Full stack, meaning?
Meaning you can still use your own back-end logic. That doesn't change.
Right.
Now you can trigger complex actions, connect specific proprietary data sources, and, this is the key part, render a fully interactive UI. We're talking buttons, maps, video players.
Right inside the chat window.
All within the existing chat window. Okay, but the devil is always in the architectural details.
Yeah.
Right? How do they handle the inherent trust issues? Third-party rendering, data transfer within their environment. And what exactly is the foundation? We keep hearing about this MCP.
Ah, yes. MCP, Manifest Content Protocol.
What is that, and why is it so key here?
That's a really essential question. The Manifest Content Protocol, or MCP, is the crucial architectural standard underpinning all of this. You can think of MCP as like an open specification. It's how external services describe to ChatGPT what content they are displaying and, importantly, how the user can interact with it.
So it's like a standardized language for trust.
That's a great way to put it. Yeah, language for trust. For a developer, if you're already using this open standard, you keep full control over your back-end logic. your front-end display, but you package it in a way the platform can securely understand and render.
So it's not just slapping an iframe in there. It's rendering a standardized component that speaks the platform's language.
Precisely. And the immediate benefit for developers: distribution. Massive potential reach.
To those hundreds of millions of weekly users.
Exactly. Hundreds of millions. Plus, they're already planning the future monetization path. That includes this new thing called the Agentic Commerce Protocol.
Agentic Commerce Protocol. Okay, that sounds important, but also potentially fraught with complications. What does agentic really imply there, beyond just instant checkout? Is it about trust again?
Well, the agentic part implies the AI itself is capable of orchestrating the entire transaction flow. So from recommending something right through to the secure payment execution.
Without a human needing to step in.
Without human handholding right within the chat. The protocol is designed to handle all that friction of checkout, offering instant purchasing. And the trust mechanism, it leans heavily on that MCP standard again to make sure the user knows exactly what they're buying, who they're buying it from, facilitating that instantaneous purchase without ever leaving the conversational context.
Reducing the clicks between inspiration and transaction to zero, basically.
That's the goal. Yeah.
Okay, let's move to what feels like the most fascinating architectural piece here. This concept they call talking to apps. This sounds like the key insight that moves it way beyond those clunky plugin attempts we saw before.
This really is the connective tissue. Talking to apps, it defines the mechanism, the specific API, by which the app's SDK exposes crucial application context back to the large language model.
Okay. So the app tells the model what's going on inside it.
Exactly. This ensures ChatGPT knows precisely what the user is interacting with, even if it's a UI component rendered by some external developer. This awareness, that's the magic. It facilitates these seamless transitions, allowing the conversation to drive the application, and, crucially, the application to inform the conversation.
Let's look at the demos they showed, because they really illustrate this dynamic context transfer well. First, that Coursera learning example. A user is watching an embedded video course right there in ChatGPT. They pause it, and they ask, can you explain more about what they're saying right now?
Okay, so traditionally, a chatbot would need you to summarize, right? Tell me what they said, give me a timestamp.
Yeah, what were they talking about?
But here's the difference. Because the Coursera app exposed the context via the app's SDK, ChatGPT knew the instructor was currently discussing some pretty specific data preparation steps for machine learning model training.
Without the user having to spell it out.
Instantly. The AI accesses that specialized context and can break down those complex terms for the user in simple language. It acts like a hyper-aware tutor right there in the moment.
Wow. It completely eliminates that friction of the context handoff. Okay, example 2, the creativity and design one with Canva. This showed more of a workflow composition, I thought.
Yeah, it did.
A user brainstorms a dog-walking business name, Walk This Wag, just in the chat. Then they ask Canva to generate a poster, specifying style requirements drawn from that prior conversation. Colorful, whimsical, bright, sans serif.
Right, and the Canva app generates the visual assets based on the history and the context of that chat discussion. But what I thought was truly compelling was the iteration speed.
Yeah, the back and forth.
Exactly. While viewing the poster, maybe full screen, the user can just ask for visual tweaks via a simple text command. Make the dog bigger, change the font color, driving design iteration without touching a mouse or a design panel.
And then the final step was asking Canva, just conversationally, to turn that poster into a pitch deck because, you know, they needed it for fundraising.
And the tool just transitions the asset from a poster to a multi-slide presentation entirely based on that conversational prompt. That's pretty sophisticated cross-functional composition happening there.
That level of multi-step action is impressive, definitely. But I think the Zillow demo is the one that truly demonstrates the kind of dynamic multi-tool composition that you need for that 6 billion token throughput we talked about.
I agree. That one really highlighted the architecture.
So a user has suggested Pittsburgh for expansion. The Zillow app gets invoked, loads an interactive map right there in line.
And this is the architectural highlight of talking to apps. Once that map is loaded, the app is active, the user asks ChatGPT to filter the results. Something like, show me 3-bedroom homes with a yard for the dog.
Which is a pretty complex filter, actually. Spatial data plus feature requirements.
Right. And ChatGPT instantaneously communicates that complex request back to the Zillow app, which updates the displayed data on the map.
Okay, but the real insight for me came next. The user selects a specific home on the map, which updates the internal context.
Yep.
and then asks ChatGPT, how close is this place to a dog park?
Exactly. And Zillow itself might not have that dog park proximity data readily available or, mapped in their system, but ChatGPT is able to instantly compose the context it just received from the Zillow app, knowing the specific home and its location with other tools it has access to, maybe search, maybe some geospatial tool.
To answer a question the core Zillow app couldn't answer on its own.
Precisely. This dynamic cross-tool workflow, all driven by natural conversation, it just maximizes the scaling potential for developers because it connects multiple specialized services on the fly based purely on the user's intent.
So the intelligence isn't just like generating text anymore.
Yeah.
It's acting as a really sophisticated API router and context manager. It's almost like a micro operating system for these apps.
That's a really good analogy. It is. And the beauty for developers is they don't necessarily have to worry about all that routing complexity.
How does that work? How do apps get found?
Well, apps are discoverable either explicitly by name, show me Zillow, or, and this is clever, they can be suggested automatically by the model based on the conversational intent. If you're discussing planning a party, the system might proactively suggest Spotify or maybe a calendar app.
Okay. So it's about being present and functional right at the point of need.
Exactly. Less friction, more doing.
Okay, so that seamless orchestration we were just talking about, filtering Zillow data, using search, converting Canva posters, that starts to demand a higher level of sophistication. That takes us, I think, from simple apps towards more complex agents.
Definitely.
And this is where traditionally developers hit a pretty solid wall. Agents, software designed to autonomously take on complex multi-step tasks using context, tools, trust, they're famously hard to get into production. The complexities around orchestration, reliability, security, evaluation, it's immense.
Yeah, that friction is exactly the problem the new agent kit is designed to tackle head-on. It's positioned as a complete set of building blocks. The idea is to take agents from that messy, often unreliable prototype stage.
We've all been there.
Right. Straight into secure, optimized production with hopefully minimal heavy lifting from the developer. Those traditional nightmares like managing the agent's internal memory, handling complex error loops elegantly, securing tool connections, that's all meant to be abstracted away by the kit.
Okay, let's break down the core components then, because it sounds like a pretty comprehensive, almost enterprise-grade suite, starting with the creation environment, the agent builder.
Right, the agent builder is crucial. It's all about visual, rapid prototyping. So instead of writing and managing heaps of complex orchestration code by hand, you design the logic steps, you test the flows, you ship your ideas using a visual canvas.
Like a flow chart almost.
Sort of, yeah. More sophisticated, but that visual paradigm. And it leverages the existing Responses API foundation, which is smart because it minimizes the learning curve for developers already familiar with the platform, and it maximizes the speed of iteration.
Makes sense. Okay, next up is the chat kit. Now, why is this component necessary? Couldn't a developer just integrate an agent into their existing UI pretty easily?
You'd think so, but they apparently realized that integrating a truly reliable, responsive, and just robust chat experience into a proprietary application is, somewhat ironically, one of the biggest bottlenecks developers face.
Building a good chat UI is hard.
It really is. So the chat kit solves this by being an instantly embeddable chat interface. Makes it easy to bring a customizable, branded, and importantly, a tested agent experience directly into your own applications. They claim it reduces the time spent on that front-end integration from potentially days down to minutes.
Okay, that's a big claim. Now let's talk quality assurance. This feels like the biggest pain point in agent development. Evils for agents. Why do these complex multi-step agents often fail standard evaluation metrics? And what does a feature like trace grading actually solve?
This is probably the most crucial technical detail in the agent kit, I think. Traditional software testing, you look at the input and the final output, right?
Did it work or not?
But agents, especially complex ones, they operate more like a black box. They make intricate, multi-step decisions, maybe using multiple tools along the way, based on the internal reasoning of the language model. So if the final output is wrong...
You have no idea where it went off the rails.
Exactly. The black box problem. Trace grading specifically addresses this. It provides a step-by-step audit trail, a trace of the agent's entire decision process. It lets developers grade individual steps within that flow. You can see why the agent chose a specific tool at a certain point or why it followed a specific path.
So you can pinpoint the failure.
Pinpoint the failure, understand the reasoning. This granular visibility, along with new features for building specific data sets for assessing individual agent nodes and even automated prompt optimization based on evils, it fundamentally changes how developers can ensure agent reliability and debug complex behaviors.
And they mentioned running evils on external models, too.
Yeah, critically, they allow running evaluations on external models right from the platform, which shows a commitment to interoperability, not just locking you into their ecosystem.
Good point. And finally, the absolutely necessary security component, the connector registry. In any real enterprise environment, agents need secure access to internal data systems, sensitive APIs.
This is completely non-negotiable for enterprise adoption. You can't have agents running wild with credentials. The connector registry is basically an admin control panel. It securely connects agents to internal tools, third-party systems. It ensures data safety, keeps all the sensitive access permissions under the enterprise's IT control.
So it manages the OAuth, the authentication tokens, all that stuff.
Exactly. It handles the mechanisms so the developer doesn't have to worry about accidentally exposing credentials within the agent's actual code or logic.
Okay, let's look at the real-world applications they share, because that's where you see the value prop. The Albertsons retail operations example, that was phenomenal for showing real-time business decision-making.
Yeah, it really highlights the speed factor. Think about Albertsons, right? Thousands of grocery stores. If they see ice cream sales suddenly drop by, say, 32% in a region.
Traditionally, that kicks off a whole process.
Right. Data extraction, reports get generated, spreadsheets fly around, meetings happen. That whole cycle could easily take a week, maybe more, just to figure out what's going on.
And by then, the moment might have passed.
Exactly. But with an agent built using the agent kit, a store associate or maybe a regional manager can just ask, what is causing this slump in ice cream sales?
And the agent.
The agent instantly analyzes context, seasonality, historical sales trends, maybe regional weather data, external pricing factors from competitors. And it doesn't just report, it recommends immediate actionable decisions like consider adjusting the display placement in aisle 5 or launch a targeted local social media ad focusing on this brand.
Wow, it turns a week-long reporting cycle into a real-time actionable decision. That is true productivity gain right there.
It really is. And similarly, that HubSpot Breeze example they showed, it illustrated more of the multi-sourced intelligence aspect.
Right, the plant question.
Yeah, a complex customer question came in about why a specific type of houseplant wasn't thriving in Arizona's climate. The Breeze agent didn't just search one database. It simultaneously searched HubSpot's own knowledge base, consulted external web sources for low-humidity plant treatments, looked up the specific customer's policy details or purchase history, and then orchestrated all those different inputs into one comprehensive, multi-solution recommendation.
So the agent is acting like this ultra-intelligent, perfectly informed orchestrator of information from different silos.
That's a perfect description, yeah.
But okay, the most compelling proof had to be the live demo, the creation and deployment of the Ask for Oj agent. The headline hook was what? Built and deployed live in under 8 minutes.
Under 8 minutes. That 8-minute build is really the mic drop moment for the agent kit. It's the proof point that the architecture, the complexity is now becoming commoditized.
How did they do it so fast?
Well, the developer started right in the agent builder, visually wiring up nodes. And the workflow design wasn't trivial. It required branching logic. It started with a categorizing agent node.
Okay, what did that do?
Its job was just to differentiate up front. Is this query about specific session info from the event, or is it just a generic question? Based on that classification, it hit an if-else node for smart writing down different paths.
So they weren't just building a linear path, they were visually constructing conditional logic flows. Pretty neat.
Exactly. Then they created specialized agents for each of those paths. There was a sessions agent, which was equipped with a secure document tool to retrieve context about specific talks, and then a separate DevDay agent, which had its own unique context files and was explicitly instructed to speak in the quirky style of their mascot, Froj.
Right, so you get specialization and persona injection easily.
Yeah. And crucially, they address security and trust right from the get-go. By including pre-built guardrails nodes right at the start of the workflow, specifically for PII masking. So ensuring that any sensitive data accidentally entered by a user gets filtered before it's processed by the LLM or presented back. They also integrated custom widgets to visually display the session details, moving beyond just raw text answers, making the output more functional and engaging.
Okay, makes sense. And the deployment part, how did that work?
That looked seamless. After hitting publish on the workflow, which presumably generated some kind of workflow ID, they used the chat kit, that embeddable UI component, specifically the React component version. They dropped it directly into the DevDay website's code, applied some quick Froge-themed visual customization via props, and it was live.
Wow.
The ability to deploy a complex, secure, multi-step, visually customized agent in less than 8 minutes, it just highlights this radical lowering of the technical barrier to entry.
The implication here feels huge. It's like the value proposition for you, the developer, shifts entirely. You're not spending your time solving the gnarly orchestration and security problems anymore.
Right, the platform handles that operational complexity.
Your job becomes designing the best possible business logic, the smartest workflow for the agent.
And speaking of smart workflows, we shift now from these general-purpose agents to the agent specialized in arguably the toughest task of all, writing software itself. The fundamental concept, the very idea of how software gets generated is really changing. It's moving beyond that traditional image of a lone programmer hunched over a keyboard, typing everything out.
Yeah, they shared some powerful anecdotes illustrating that change, didn't they? The 89-year-old Japanese retiree who apparently built 11 iPhone apps using AI assistants.
Incredible story.
Or the med students building a virtual patient app to practice difficult, maybe sensitive human conversations. AI has transformed from just a tool you might use occasionally into this indispensable, almost ubiquitous teammate.
That's really the perfect foundation for the big announcement here. Codex, their software engineering agent, has officially moved out of its research preview phase. It's now generally available GA.
And GA isn't just a label change, right? That implies a massive commitment to reliability, stability, performance at scale.
Exactly. It means enterprises can start building critical workflows on it with confidence. And it's running on a new engine now. Codex operates on the specialized GPT-5 Codex model.
Okay, specifically trained for agentic coding. What does that actually mean in terms of architectural capability? What makes it different?
It means it's deeply optimized for the unique demands of software creation, going far beyond just, generating simple code snippets. The training focused heavily on tasks like understanding entire code bases for complex refactoring jobs.
Which is really hard for AI.
Extremely hard. Accurately performing comprehensive code reviews, finding subtle bugs or security issues, and interestingly, dynamically managing its own computational resources, so it can apparently adjust its thinking time based on the complexity of the programming task at hand.
Ensuring efficient resource allocation. So it's not just smarter, it's a better digital engineer.
That's the idea, yeah.
And the usage metrics they shared suggest developers are already treating it that way. Daily messages. So, the tasks and conversations developers are having with Codex are reportedly up 10x since early August.
10 times. And the sheer scale is mind-blowing. Since its release, this GPT-5 Codex model has apparently served over 40 trillion tokens.
Trillion.
That metric alone apparently places it among the fastest growing and most heavily utilized models they have ever shipped. This isn't just like casual popularity. It suggests deep integration into the daily development workflow worldwide.
And internally, they're using their own tools as proof points, which is always telling. They stated that their own engineers using Codex complete 70% more pull requests weekly.
70%.
And that nearly every internal pull request at OpenAI now goes through a Codex review first.
That internal adoption stat is huge. It shows the model is performing at essentially a high senior engineer level, providing depth of analysis, security checks, consistency enforcement that are likely faster and more comprehensive than many manual review processes. This moves AI squarely into mission-critical systems development.
Okay, now here's where we need to inject some critical thinking, maybe some friction. If these tools are becoming so capable, complex, secure agents built in 8 minutes, code review speed jumping by 70%, what does this mean for the professional developer? Where does the human value shift when the machine can handle so much of the traditional keystroke work?
That is absolutely the right question to be asking, and the value definitely shifts. It moves away from the manual labor aspect, the hours spent typing boilerplate code, debugging simple syntax errors, or painstakingly reading through dense protocol documentation.
Like that Visk example we'll get to.
Exactly. The value shifts towards architectural leadership and system design. The human developer becomes the orchestrator, the systems architect, the strategic thinker, the final approver, ensuring the design aligns perfectly with business goals and ethical considerations. The complexity of the job doesn't disappear, it elevates. You move from just writing the lines of code to managing the complex, multi-step agentic execution of the system.
Got it. So to support this new reality, they also introduced some critical enterprise features for codecs, the Slack integration, for instance. That allows teams to ask codecs to write code or answer technical questions directly within their existing team conversations.
Yeah, embedding it right into the workflow. And equally important, I think, for customization and scale is the Codex SDK. This allows engineering teams to extend and automate codecs within their own existing custom internal workflows, turning it into a programmable component within their specific DevOps pipeline.
So you can integrate it deeply.
Right. And for large organizations, the new admin tools providing environment controls, monitoring dashboards, usage analytics, those are crucial for compliance, security, and just managing costs and performance at scale. The fact that Cisco apparently reported 50% faster code reviews and reduced project timelines from weeks down to days after rolling out codecs, that really demonstrates the potential ROI for large-scale enterprise adoption.
Okay, let's get to that demonstration, because the on-the-fly demo of turning a physical stage environment into working software using only voice and natural language, that was truly an epic story of agentic capability in action. The challenge was building a system to control a physical camera and the stage lighting system just by talking to it.
It was a monumental feat, honestly, and it showcased pretty much every pillar of the new codex model working together. It started relatively simply with scaffolding. The developer used the codex CLI, described a basic control panel interface from just a quick sketch. And Codex not only generated the UI code, but even understood the request to pull specific branding colors directly from a Figma file to render the UI instantly. Still, 0 lines of actual code typed by the human developer at this point.
Okay, step 1, scaffolding. Step 2 felt like the technical breakthrough, protocol discovery. The developer asked Codex to control a specific professional-grade camera, a Sony FR7. Now, this required communicating with a decades-old proprietary standard.
And this is where the agentic intelligence really shines. Codex didn't need the developer to feed it documentation. It apparently discovered the specific, somewhat ancient Visca protocol needed for that camera.
Visca? I haven't heard that name in years.
Right. It wrote a functional Node.js server to handle it, figured out how to generate and send the complex UDP packets, including the specific headers required to communicate with that specific camera model. A human developer performing that task manually. That would have been hours, maybe days, buried in obscure, potentially contradictory old documentation.
Codex solved it in seconds. The machine acted as an instant expert on legacy hardware protocols. Wild. Okay, step 3 showed continuous adaptation and integrating physical input. The developer asked Codex, using an IDE extension task, to wire up an Xbox wireless controller for camera control.
Yeah, and leveraging its auto context feature, Codex understood the intent with just short, natural language prompts. It automatically figured out that the joystick input was the logical control mechanism for the camera's pan and tilt functions. It connected the virtual input from the controller to the physical output controlling the camera without needing explicit mapping instructions from the developer.
Make the controller move the camera. Just understood the intent. Okay, the height of the agentic behavior, I thought, came in step 4. Wiring up the venue's actual lighting system to an MCP server. This required interacting with a completely different physical system.
And this is the definition of agentic behavior in coding. The GPT-5 Codex model, right there during the task execution, demonstrated true external tool use. It apparently went out, found the specific lighting system's public GitHub documentation online, parsed it, determined the necessary DMX lighting commands like realizing command 8 controlled the dimmer intensity.
It figured that out itself.
It figured that out itself from the docs. And then it autonomously wrote the server code required to integrate that lighting system into the control panel. It didn't just generate code based on instructions. It actively researched, understood, and applied external documentation context on the fly.
That's incredible. Okay, the final step, using the real-time API and the new Codex SDK was almost a look into the future of creative programming. The developer used voice commands to control the lights, dim the lights, shine spotlights, and then critically asked the voice agent to reprogram the application itself on the fly, asking it to show a credits overlay naming the audience as the cast.
And the app updated the running UI and displayed the scrolling credits roll, all driven by that single voice prompt.
So the AI is not just writing code anymore. It's editing, compiling, and deploying running applications based on high-level human intent expressed through voice.
The conclusion feels pretty unambiguous. We seem to have moved beyond just manually writing software line by line towards managing complex, multi-step agentic execution cycles almost entirely through natural language.
Okay, so underneath all these really remarkable developer tools, the apps, SDK, the agent kit, the GA codecs, are the foundational models themselves. And they're continuously evolving too, right? In intelligence, efficiency, and creative capability.
Exactly. The intelligence itself is getting more specialized for the kinds of challenges developers are facing now. They detailed some significant updates, starting with just raw intelligence, particularly for high-stakes domains, GPT-5 Pro.
GPT-5 Pro. Okay, it's positioned as the most intelligent model they've shipped. What makes it pro, and why is that essential for enterprise use cases?
Well, its pro status seems to come from its design being specifically tailored for those really high-stakes tasks where the cost of an error is just immense. We're talking about critical applications in, say, finance.
Like compliance analysis.
Compliance analysis, yeah. Or legal, maybe contract synthesis, sophisticated risk assessment, and healthcare, things like clinical decision support systems. These domains demand incredible depth of reasoning, extremely high accuracy, and the ability to handle ambiguity with reliable, well-calibrated probabilistic output. GPT-5 Pro is basically the brain developers will reach for when reliability absolutely cannot be compromised.
Makes sense. Okay, next, they focused quite a bit on voice interaction. They seem to believe it's going to rapidly become one of the primary ways people interact with AI. And this is addressed with the GPT real-time mini model.
Yeah, the introduction of the mini model here is really an architectural nod towards efficiency and scalability. It's designed as a smaller, highly efficient version of their advanced voice model. And the key point is it's significantly cheaper. They said 70% cheaper.
70% cheaper.
Which suddenly makes real-time, high-quality voice processing economically viable at massive scale.
Okay, but is there a quality trade-off when you go mini? Does the expressiveness or the responsiveness suffer noticeably?
That seems to be the key technical achievement they're claiming. They stress that it maintains the same high voice quality and the same emotional expressiveness as the full-size model. The compromise is primarily in the computational footprint, the efficiency, not the perceived quality of the output.
Okay, that's vital then for deploying real-time voice interaction widely, especially on mobile devices or maybe edge computing environments. It makes the whole voice ecosystem faster and more scalable for potentially billions of users.
Exactly.
All right, finally, we turn to what feels like a massive leap in creativity. The highly anticipated Sora 2 preview in the API. This opens up their state-of-the-art video generation model directly to developers, letting them integrate it into custom applications.
Yeah, Sora 2 represents a major push towards giving creators more control. Previously, AI video generation, while amazing, often lacked that fine-grained control over the scene, the composition, the consistency.
Right, it could be a bit random sometimes.
Exactly. The key improvement here is controllability. Users can now provide much more detailed instructions, and the model apparently holds on to the desired state much better, delivering results that are visually accurate, stylistically consistent, and compositionally stable over time.
Like that example they showed of taking a simple iPhone screen view and prompting Sora to expand it into this sweeping cinematic wide shot while maintaining perfect visual coherence and object continuity throughout the transition.
Exactly that kind of control. And the feature that really makes this a creative powerhouse, I think, is the new sound pairing.
Ah, yes. Tell me about that.
The model now generates realistic, synchronized sound, and not just, speech recognition output, but rich ambient soundscapes, background audio, environmental effects, all perfectly grounded in the visuals happening on screen. They use that kayak video example.
Right, with the water sounds.
Yeah, to show how the sound of the water lapping against the kayak, the paddle strokes hitting the water, it's all integrated naturally and accurately with the visual motion in the video.
That opens up applications far beyond just making cool short films, I imagine.
Oh, absolutely. Think about concept development in marketing. Maybe generating e-commerce ads based on just a general vibe or a product sketch almost instantly.
Wow.
Or integrating real-world elements. Taking a picture of your dog, like in the demo, and using the model to seamlessly integrate your actual dog into a completely new, maybe animated environment with new stylized friends interacting with it.
That's pretty amazing. And the practical application they cited from industry. Mattel, was it?
Yeah, Mattel. They're apparently using Sora 2 in the API to accelerate their product idea realization process. Their designers can start with just a simple sketch or maybe a mood board and then rapidly turn those early concepts into shareable, workable video designs.
So it dramatically reduces the time it takes to vet an idea from just a concept to a compelling motion prototype.
Exactly. It reinforces that whole overall theme we've been seeing, this massive compression of the idea to product timeline across the board. And developers also retain crucial flexibility controlling video length, aspect ratio, resolution, and even easily remixing existing video clips through the API. Hashtag tag tag outro.
What a phenomenal body of work, really.
Mm-hmm.
We've covered these 4 huge pillars enabling this exponential scale. The app's SDK, which effectively turns ChatGPT into an interactive application canvas.
Mm-hmm.
The agent kit, which looks like it drastically simplifies the deployment of complex, secure, and properly evaluated agents.
Yeah, it takes out a lot of the pain.
A GA codex running on that specialized GPT-5 engine, which we saw can literally program physical systems via voice commands.
Still kind of blown away by that demo.
Right. And finally, these powerful underlying model updates with GPT-5 Pro for high-stakes reasoning and Sword 2 for hyper-controllable sound-paired video generation. The conclusion, it feels like, is unified across all of them. The friction points of implementation have been almost entirely removed, or at least drastically lowered.
It really feels like a complete decoupling of having a great idea from the often immense technical drudgery that used to be required to realize it. Those reported metrics, that 6 billion tokens processed per minute, the 10x growth in codex usage, they demonstrate that developers aren't just hungry for the speed, they are actively utilizing these tools right now to perform tasks that were previously impossible or maybe reserved only for highly specialized large teams.
The ultimate realization, maybe, is that builders are achieving these incredibly complex tasks, orchestrating multi-step agents, controlling physical devices like lights and cameras, even reprogramming their own applications on the fly, often without writing the underlying boilerplate code by hand. AI has truly become this universal productivity partner, taking on so much of the burden of technical execution.
So, what does this new reality mean for you listening? For you, the learner, the entrepreneur, the innovator out there. It means your primary value proposition is perhaps no longer tied solely to the hours you spend on manual implementation, on finding that obscure Visca protocol documentation online, or configuring complex evaluation loops for an agent, or managing authentication schemas securely via something like the connector registry.
The platform handles more of that complexity now.
Exactly. The platform handles that. Your focus, your energy shifts entirely to higher level concerns. System design, ensuring trust and security using those built-in guardrails, and maybe most importantly, identifying and executing on a genuinely good, novel idea. Software development cycles that used to take months or even years, well, they showed us that significant complexity can now potentially be deployed, tested, and even edited in minutes.
That brings us perfectly to our final, provocative question for you to consider as you reflect on this deep dive. Given that these technical constraints have been so radically lowered, and the tools now exist to build an application, deploy an agent, and code a complex solution almost entirely via natural language and visual editors, what is the most ambitious and complex project that only your imagination, and not your technical limitations, has been holding you back from building until now?